Okay, the next couple of examples are called quotient of powers. So last video we talked about product of powers. Now we're dealing with quotient. When we hear the word quotient, what do we think of? Very good. We think of division. All right, so now we're dividing. And what are we going to do now that we're dividing? Well, to divide powers with the same base, we subtract their exponents. So that's interesting. When we multiplied the bases, we added the exponents. When we divide the bases, we subtract the exponents. So let's look at a few examples here. I've got 4 to the 8th power divided by 4 to the 2nd power. I have the same base. It's being divided. So I take the one power and subtract the other one. So 8 minus 2 equals 6. Therefore, my answer is 4 to the 6th power. Another example along the same lines would be this one here. 6 to the 12th divided by 6 to the 2nd power. I have the same base. It's being divided. 12 minus 2 is 10. So the answer for this one would be 6 to the 10th power. So that would be an example of some of your more basic power problems where division is involved. The next example is the same thing pretty much, but once again, we're using variables. So I have n to the 9th power divided by n to the 4th. So the fact that our base is a variable does not change the rule at all. When we're dividing powers with the similar bases, we subtract the powers. So 9 minus 4 equals 5. So my answer will be n to the 5th power. Let's check out one more example like that. Here we have, if you can see it, it's kind of dull. A to the 14th power divided by a to the 8th. Okay, do I have the same base? Yes, they're both a. So what am I going to do with the exponents? Because I'm dividing, I'm going to subtract. 14 minus 8. 14 minus 8 equals what? 6. So my answer in this case would be a to the 6th power. All right, so far, whether we have integers or numbers, or whether we have variables, the rule applies. If I am dividing the bases, I subtract the exponents. One more example. Example number 6. I have 2 to the 5th power times 3 to the 5th power times 5 to the 2nd power. All of that is over 2 to the 2nd times 3 to the 4th times 5. Now, the first thing I'm going to suggest that you do is when you see this 5 all by itself, what exponent is really there? Correct, Nick. The exponent is 1. So I would suggest that you go ahead and write that in so you don't forget about it. Now, they actually have this beautifully set up for us. They've already got it separated, right? We've got base of 2 here, base of 3 here, all right, and base of 5 here. So I can look right here and say, all right, we're dividing the same base. I'm going to subtract 5 minus 2, and that'll give me 2 to the 3rd power. 3 to the 5th and 3 to the 4th have the same base. What's 5 minus 4? 1. So I can write that 3 to the 1st power, or just leave it without an exponent. And then over here, I have 5 squared times 5 to the 1st. 2 minus 1 equals 1. So once again, I can write this as 5 to the 1st power, or just 5. So our answer we get in that situation is 2 to the 3rd times 3, or 3 to the 1st times 5. All right? And then if you want to actually solve that, you can go ahead and do that, no problem. All right, let's do one more example like that because those are a little bit more complicated. All right, in this last example, I have 2 to the 5th times 5 to the third times 9 squared divided by 2 to the third times 5 times 9. So once again, we're going to make sure that we put in our exponents there so we don't forget about them. Over here, 2 to the fourth and 2 to the third means I can subtract the exponents. 4 minus 3 equals 1. So I have 2 to the first power. Here I have 5 to the third minus 5 to the first, so I can do 3 minus 1, and that equals 2. So 5 to the second power. Here I have 9 squared minus 9 to the first, so 2 minus 1 equals 1. So I have 9 to the first power. Or I can simply rewrite that as 2 times 5 squared times 9, and then solving that for an answer would be very easy from there. So what are the keys to remember? First of all, if you don't have an exponent, if you don't see an exponent, the exponent is 1. And when you see us dividing, make sure that you subtract exponents. If we're dividing the same base, subtract the exponents. And as they did in the examples for us, make sure that you rearrange the multiplication a little bit so that you can set up bases that are similar. Thank you very much for your attention. You may now work on the got it problems.